So what are we going to do now? I'm assuming you know a bit of React already. If you do not, not going to waste time on React. There are plenty of recordings everywhere, even on my YouTube channel there's a full React course, so you'll be fine. You should be able to find it without issues. So now I would really like to dive into things in one go. Okay, so I'm going to define an interface which is a widget with a given output. Because if you think about a React component at its core, and actually I'm going to define this as a widget, I'm going to as an interface, but just a type. A React component always has a given output that is passed as a parameter to a callback. So I will define the widget as, well, I will give it a traditional method that is run. It takes as input the callback, set state, on done, on value, on output. Yes, on output. On output will take as input a value of type O, which is our output, and further do nothing. And then run will return a JSX.element. This is something that we call working with continuations. And in particular, this on output function here is the continuation, and the continuation is a callback or a parameter function that we call with the results. So instead of returning the result, we pass it to the continuation. It's actually quite cool, right? Because passing your result to whoever is consuming it or returning it is kind of the same. But why don't we just return it? Because what we want to return is a living object that we want to render on the screen. Of course, if we have a widget of O that can return values of type O, not really return, but propagate or signal values of type O, and that is the output of the coroutine, output in the sense of the data output, for example, a checkbox. Whenever we click it, the output is I go to true, then I go to false, so the O will be Boolean and it will be first true, then false, then true, then false. How many times? How many outputs? Maybe 0 if no one ever clicks that particular checkbox. Maybe 1 if it's clicked 1. Maybe 100 if the person is bored and keeps clicking the checkbox. So how many outputs does a widget have over time, potentially? Well, unbound. There's no limit. But in the meantime, the widget always renders on the screen if it's active. So that's why it always immediately returns the JSX.element, and this JSX.element hides the logic that determines whether or not we're going to call the output. And what you can also see is that the widget is basically just a little thin wrapper interface on the JSX.element, because the JSX.element simply says from React, I render. And that says nothing. We don't really care about things rendering. Come on, we're software engineers. We care about data. How does the data flow through our application? Okay. And we're not just any software engineer. We are the best of the best. So we know that if the widget has a sort is like this box over time, similar to a coroutine. I wonder if there's a connection there. We'll think about it. But anyway, it's a container over time that will fill with this potentially infinite stream of outputs of type O. And we know that containers can be transformed. So we will anticipate immediately on the fact that we kind of really secretly expect that if you give us a function. So here I don't have the whole framework we built last time. For now I'm just doing this in isolation. If you give us a function from O into O2, so from original output into new output, yeah, whatever, O2, this should be able to give us a widget of O2. Okay. Armed with this, we actually have enough. So we need a constructor of a widget. So I will define the usual repository. then default. How do we create a widget? Well, actually, we create a widget of type output. Oh, pro tip. Took me a while to discover this actually. When you have a single type argument in a TSX file, in order for TypeScript to and JavaScript to properly understand that this is not a tag, so we don't want to close it, like it's uselessly prompting us to do, you add a trailing comma, everything becomes speech. Okay, so, and what I get here is the actual component. So the actual component takes as input on output, returns the JSX.element, and well, we have to turn this into a widget of O. So how will we do this? Now, we create the widget where run is this actual thing, and then map, okay, map will be a function, O2, then, well, you know what, let me copy this. Okay, very good. How do we map? Well, oh, how about this being a widget of O? Also very useful. Okay, so we return widget default. Now, this takes an output of O2. So actually, let's pass this output. But the real work will be done by this dot run. Now we can intercept the outputs of type O from the original widget. And then these outputs, what do we do with them? Well, we have to pass them to the expected output O2 transformed by F. There you go. And you could actually imagine that if we had our framework of functions, we could simply say F then on output, and perhaps we will do it later. But for now, we're starting in a new domain, and then we will connect the domains another time. Okay. Another very cute and useful thing that I actually like to have is the so-called rep HTML function. So, because we actually have two things here that we can transform. The most important is we can transform the output. So this is the data transformation. But actually, we can also transform the rendering by putting a sort of, like this map creates a sort of proxy widget that intercepts the output of one widget, of the original widget, and transforms it somehow into a new output by applying function F. But actually, we could also intercept the way the widget looks like and maybe wrap it with something else. So rep HTML will take as input a function from JSX element, so the original rendering into the new rendering, and returns a widget which is obviously unchanged in output. Okay, so now let's take map. We will do exactly the same. We also need this. Here we change, and now we can return a new widget. What this widget does is well, here default what it needs to return now is a JSX element, so we can say okay, F of, well, of the JSX element that comes out of this, so this, but now I need to call this, I need to run it. I intercept the value, well, I don't even need to intercept the values of O, so I can simply say, okay, whenever this has an output, we just pass it to an output, but we've just created a sort of proxy container widget that hijacks the rendering, but passes whatever output from the current widget to whatever output this proxy is supposed to return. All right, now, so let's define a hello world being a widget that produces, well, a widget that produces string output. Like this widget framework is entirely focused on propagating data, just like the state monad, the coroutine monad, the widget, the widget is just a functor, but we could turn it into a monad. But joining widgets doesn't happen that often. We don't really need to flatten or den widgets because we tend to put them all on the screen and they run in parallel. But anyway, we are going to manipulate. We're going to build a text box. We're going to take as input the current text, which is a string. And then we want to create a widget of, well, the new text as modified by the user. And we can say, okay, how do we create this? Well, widget.default. And here we say on output. And here we can render stuff. We can say h1, hello to the wonderful world of widgets. Here we can put an input, and the value will be the current text. And on change, okay, we get the event handler we call on output of e.current target .value. And let's not run anything here, just run hello world. Hello world needs to get the current text. Okay, great. So text. Then we need to call run. We could have done this in a very fancy way by saying that the widget is that basically we make the widgets renderable by doing something fancy like this, and this is a bit of extra complexity, but for now we just call on run. Here, when we get the new value, we are supposed to do something with it, ideally save it in the state. We will do it later, but for now we are just going to alert new value, and then new value. Okay, so we're not saving this in any way, which is kind of silly for now. But okay, so you can see already that my skills as a front-end developer, when it comes to making things pretty, are worthless. This will stick forever. I suck. I'm not colorblind, but I might as well be. Okay, so we have the text, which is great because that's what we're getting. So let's say that has 3 dots. There are 3 dots. Okay, great. And if I type a 4th dot, well, nothing is happening, but I get new value. And well, if you can count, you can see 1, 2, 3, 4. Okay, good. But nothing is happening to the state, so we're not really there yet. Okay, so let's put this in. Let's remove this thing that we're importing, and let's say that the app doesn't really have any props. Then const state set state is useState of an empty string. So we start with an empty string. Then we return the JSX element. So this is fine. So now app should know, okay, it's a JSX element. Very good. And here we can uncomment this. So everything happened. Actually, you know what? Initial text. Let's get it as a string so we can pass it. We make it customizable. Props initial text. Let's behave, you know. Initial text. For now, let's start empty. And here, finally, when we get a new value, well, what we can do is we set the state to new value. And of course, we'll pass the state here. Let's refresh. Everything starts as empty. And now you can see, okay, it's not really mind-blowing, I admit, but it is working and it is very well disciplined. All right. Now we take a quick break, and what we're going to do after the quick break is going to be, well, we will restore fun and updater, because we really want. We will implement the parallel operator any. So there is, I think things keep happening in the same way. And finally, we will implement a parent-child embedding system that scales to infinity. Yes? So do you see how the widgets emphasize data processing? Because if I give you a normal React component, it might contain stateful things, etc. You have no idea what it really does. But the widgets, they really make it clear. You get from me this. So this widget here, this hello world, is very clearly something that gives you text back. We could even actually swap this a little bit. We could say, okay, because I want the div and hello and the div and the h1, but I also want to isolate this this input. So what I'm going to do is I'm going to say, you know what? I'm going to define a text input, and this is a text input. It's very neatly isolated. And a hello world will, well, we want to run the text input here. So what we can do is we can say, okay, you know what? Take the text input, pass it the current text, and then wrap the HTML. Let's say underscore is, well, the output of the text input. This is what we want to have as a wrapper. And now you can also see that what we've achieved is that this kind of, let's say, wrapping template is a way, well, let's test it. Still works, but we've separated the input processing and data processing entity in our domain from the purely rendering wrapper. This is the easiest form of composition. Okay, now let's go fetch the things, the wonderful little things we've built so far. Wait a second. Yes, live coding, index. The only things I really want are, yes. Oh, well, actually, oh, this is very nice. But we're going to rewrite it. Okay, so we're going to take the function, the updater, and the identity. Then we move back to React. No, I don't want to save my workspace as a configuration file. And here, now it's all kind of disorganized in the same file. We also don't care that much about apply. And here the identity has a single parameter. So there we go. But now we have the function, and we have the updater. Okay, very good. All right, what's the updater useful for? And let me take a look. Now what I'm also going to do, I'm going to simplify this a little bit. I'm going to say that other is going to be like a normal lambda from output to next output. Why? Because this way, if you have a function like a fun, then we can say fun.then. But what you pass doesn't need to be a function, doesn't need to be a fun, but it doesn't matter because what you get as output, is again a fun. So the second argument, we're lifting the requirement because it's not strictly needed. So it's not the prettiest, but it's very pragmatic, this thing. Okay, cool. So now I'm going to define a type, person. So I have the text input, and you can imagine this text input is something that, well, it's just useful. Okay, and the person has a name and a surname. Imagine that I could have text input, I could have number input, I could have date input, I could have checkbox input. The thing that changes would be that, okay, so for example, for a Boolean input, the current value would be a Boolean, the widget would return signals of type boolean, and here we would need to change the implementation, so blah blah blah, and this is just a matter of googling how do you implement a checkbox. So I'm not going to waste time on this. I'm just going to assume we can do whatever we want, but for now I'm going to show how to work with strings, and especially how to work with a smaller widget that operates on just a string and turn it into a widget that operates on a whole person. So this is a form of vertical composition, putting smaller things inside a bigger context. Okay, so the name input. Well, the name input will take as input a person and return a widget of person of which the name might be changing. So this would be, actually, this doesn't even need to be built as from the constructor. I can say, okay, you know what? The name input is actually a text input. What do we pass? Well, I take the person and I pass the name. And then, well, the complaint now is that this is a widget of string. But what we want is a widget of person. How do we do this? Well, we say, okay, we map. And how do we map? Well, we have a string and we have to put it in a person. So let's say I get here the new name and I return a person where the name is the new name. And lo and behold, everything works. Oh, and map? Okay, map here doesn't really know that what I'm supposed to return is a person, so I'm going to give the hint so that, well, here we actually see, okay, this thing doesn't just give a record that has a name which is a string on top of person. This actually knows what you're getting is a person. Okay, so now I could say that my hello, oh, and let's also say that I want the surname input. Why not? And the surname input also operates on a person. What we pass to the text input now is the surname. What we get is the new surname. And there you go. So now I have the name input and the surname input. And now hello world, actually I'm going to turn it into a widget that manipulates people. Of course I can't invoke text input here, but I can call name input. I can pass the person and then just wrap the HTML anyway. Of course this is broken now because, well, the app doesn't manipulate text. So I'm going to say initial person here of type person. So this becomes our state of type person. Another thing is actually happy. Well, of course, now I need to initialize the person. So here I'm going to put the name being John, the surname being Doe. We run this. And now I'm changing the name of John Doe. Okay, how do we actually get to see that this thing is working? We get to see that this thing is working because I could, for example, as a way of debugging, just put the person value right after the widget that we're wrapping. So you can see now John Doe. So this gives us a debugger insight in the state, and you can see that the state is changing as we would like to. And if instead of name input here I put surname input, let's see. Okay, now we see Doe, Doe doctor, or Dr. Doe, and you see it works. Okay, what do we want to do next? What we want to do next, ideally, is if we have two widgets of person, I kind of want to say, how about you put them both on the screen, and whichever says what the new value of the person is, give me that. And this we call any. So let's define the any combinator, and we will define it here on the widget itself. Okay, any. What does any take? Well, it fixes the output, and it takes as input, guess what? A bunch of widgets, which are an array of widgets all of the same output, because if they do not have the same output, then yeah, we can't really do much. So they have to all give the same output, and then we return a single widget, mind you, just a single widget, and the single widget is going to trigger whenever any of the widgets triggered. So if I have something that is waiting for the user to type in the new name, something the new surname, something the new age, etc., it doesn't matter because they all yield a new person, and so that becomes the new person that we pass on. Okay, so how do we implement this? Well, we could say widget dot default of O on output will, and you notice that also here any also needs to run the widget. So here, just like for the coroutines, when you have these things that run stuff in parallel, you need to understand what does it mean to run something. So we always need to create a default. Yeah, just like for map actually. So these are, let's say, very low level operators, but they are quite recurrent. Okay, so what do we do here? Well, we render a React fragment, and inside the React fragment, we take all the widgets. For each one of these widgets, we run it. And if the widget wants to trigger, well, we simply say, okay, if you want to trigger, just tell on output. This could actually be turned into a one-liner if we wanted. I don't know if it's a good idea. It's always a good idea to turn stuff into a one-liner. There you go. So this is simply saying, yeah, render all of them, whichever triggers, well, pass on the output of that one that triggered, because it's the only one, the others are inactive. And this is the output of the whole any. So now, what I can say is that I take widget.any and pass surname input, but also name input of the same person. And then I can wrap the HTML of the whole any. What is going to happen? Now I get two text boxes. John, John Jr., for example, and Doe, and Dr. Doe. And you might say, okay, but what if I want to also add a div around these things? Oh, it's okay, you can wrap the HTML of them. For example, you can say, okay, just put a, just put a div around the first and a div around the second. We could even turn this into a utility, but for now I'm just going to be a little bit lazy, and now you can see they are on different lines. I'm not going to make any attempt at making this pretty, because again, I would just miserably fail at it. But you can now see the power, the compositional power of this thing. Cooler. Alright. And did you notice that the signature of n is exactly the same signature that we had? Like exactly. 100%. Alright. Alright. Now, what I'm going to do is I'm going to introduce this idea of updaters. So instead of saying that a widget can return whatever output, and instead of returning as output, the new value, I'm going to return an updater of that value, so that we always have the ability of specify from a widget the change we want to apply rather than the new value we want to calculate. Okay, and I'm going to define a new operator, which I'm going to call replace with. Replace with takes as input a value, the new value of type A, and it returns an updater of A. And this updater of A is built as a function that takes a value and ignores it, just returns the new value. So here, what I can say is, okay, so the output now is an updater. So I say, okay, I create an updater that will get a string as input, but simply replace it with e.currentTarget.value. Okay. Now, for the person, what are we going to do? For the person, we are going to define our updaters. So we will have the name updater, which takes as input the field updater, so an updater of string, returns an updater of person. Because these things are done so often that, you know what, I would much rather be a little bit lazy, because this kind of thing is a tiny little bit tedious to write, so I'd rather write it only once in this sort of repository object. And I'm actually going to put it in an updaters container. Why not? Okay, so here, well, name is not going to be new name, but rather I'm going to call the name updater on person.name. Okay, I'm going to copy this. In case you're wondering, yes, there is a way of automating the generation of this whole thing, but we're not going to do it today. But it is possible. You can enjoy yourself by hammering on it. Okay, so now I have the text input. The text input produces an updater of string. So what I can say is that here, instead of returning a person, well, I'm going to return an updater of person. And here, what I'm going to pass is, okay, let's take a look at what we're supposed to do. We will receive an updater of string and return an updater of person. Magic is about to happen. Are you ready for some magic? Magic. Person dot updaters dot name. And actually, okay, let's see this other. So this text input, it gives us an updater of string because it says, okay, this is what you're supposed to update. Well, it will be a replace with, but we don't care because it's updaters all the way down after all. An updater of string, but we have to return an updater of person. And now they have to have the same type because otherwise we can't put them in an any. So now we get updater of string into an updater of person. So this basically means, okay, the text simply knows that there's new text for you, an updater of string, but where do we put it in the person? Well, how about in the surname? Mind blown again. All right, and now, well, this thing should be kind of happy, but well, of course, we need to return an updater of person, so everything is happy. What is the thing that's... Ooh. Why does hello world that returns an updater of person still work? Because this new value is not a person, but an updater of person. It just so happens that set state in React actually can deal with updaters. So we could have also just said this. Let me test it. Yes. This works. Okay. What if I said that we have pair programmers, where we have programmer 1 being a person and programmer 2 being a person. Okay, and now I define pair programmers, here programmer 1, here programmer 2. Bear with me for a second. So we get an updater of person and we return an updater of pair programmers. Oh wait, why is it unhappy? It should be unhappy. Okay, so here we get the pair programmers, and we create a whole copy of the pair programmers where programmer 1 is the updater underscore on pair programmer.programmer1, and here we do exactly the same for programmer 2, but we embed the value in programmer 2 after transforming programmer 2 itself. Okay, so let's say that instead of initial person, we get programmer 1. I'm even going to drop initial programmer 1 and programmer 2. Here, as state, I'm going to be quite clear. I'm going to say we get pair programmers. So we get props dot, apologies, we get, I can just pass the props actually, because they have the same type. Okay, that was lucky. Now, of course, hello world now complains. Makes perfect sense, because hello world should now get the pair programmers. Okay, all right, pair programmers. and it returns an updater of pair programming. The thing that obviously breaks is that here we have this name input and surname input, and they don't really work. So let's add one level of indirection. The person is now a widget that takes as input a person, returns a widget of an updater of person, and, well, widget any with the name and the surname with the little divs at least to get the two input boxes look a little bit more decent. Of course this doesn't work, but we're going to fix it in a moment. Then let's define a pair programmers widget, and we take as input, well, the pair programmers, which are a pair programmer, and we return a widget of updater of pair programmer. And here, what are we going to do? I wonder. Well, we have one person, which is pair programmers dot programmer one. And what do we do with the output of pair programmer one? Because this gives us. Wait, let me comment all of this away so we get clear intelligence. This gives us an updater of person because this is what happens to pair programmer one. But now we need to produce an updater of pair programmers that embeds the updater of person into an updater of pair programmers, and this is pair programmers.updaters.programmer1. And we can also wrap the HTML if we want, just add another div or not, and then we pass pair programmer2 to person still because it's the same logic, and we want to take whatever comes out of the person updater of the second one and put it in programmer2. Now, here, we can simply put pair programmers. We need to pass, programmers, this is just the data, and we pass programmers to the pair programmers widget, and, of course, now we have two, so now obviously the state has to grow up a little, bit, so we have programmer 1, this will be John Doe, and programmer 2 will be Jane Doe, and there you go, John Doe, Jane Doe, and where? Person is trying to render the widget now, but that makes no sense. We have to render the whole state. Okay, now we can see John Doe, Jane Doe, and if we, well, okay, this will be Jane Jr. or Jeanette, and this will become Johnny, and Doe, well, Dane, whatever. And you can see the thing still works. And what has happened? What happened is that we found out that our basic framework of functions and updaters, and especially the embedding of updaters into child updaters or embedding of child updaters into parent updaters, depending on how you prefer to look at it, actually transfers also into the embedding of child widgets into parent widgets. And this happens very naturally. We've also seen that this functorial structure of widgets, because widgets are streams of data, then an operator like any is identical to the any of coroutines. So we see that these things keep happening, they keep connecting with each other, and this connection maintains this property that we know how composition works, and we know what the signatures are supposed to be, and we know that the logic is supposed to be simple, and this makes it possible not only to build tools that allow us to manage very complex problems, because the problem of composition of child components into parent components at scale is a very complicated problem. It's much more complicated than building a React, Vue, or Angular Hello World. Like, everyone can do that. But how do you build an application where the pattern of composition of state propagation changes is the same? It doesn't matter at which level. And if you look at, the person updaters, the person domain is closed, it's finished, it's done. And then we have a domain that we build on top of the person domain, but person domain has no clue about where it's being used, which is the point of abstraction and composition. And then we have the name input, and this is, an updater of person. And then we have a way to turn an updater of person into an updater of pair programmer. And you can see that this is happening at all levels, like from string to person, great, but the text input is also closed, because it's done. It's done forever. And the name input and the surname input, these are the updaters of person. Great. And then we have the full updater of person. So we went from, this is vertical composition from string to person. This is also vertical composition from string to person, because vertical is going up in the hierarchy of complexity, we're broadening. But then any allows us horizontal composition. We have multiple things in the same domain and we put them in parallel. Okay, great. And then this here, well, here we have an example of vertical composition because it's from person into pair programmers, and horizontal composition because I have two pair programmers or two widgets over the pair programmer. The amount of control and the amount of quiet reasoning that you can extract from working this way, I have some trouble being able to explain how much easier life becomes. Because the moment you realize that you don't need to figure new things out, the moment you realize that stuff is the same, that there is so much similarity, that so many things that feel different actually aren't, means that you start seeing the hidden patterns and you can leverage them to work a lot less hard and a lot more effectively. I have to say this touches me quite a lot, more than I would expect. So, as always, I want to thank you for being here and for sharing this journey, because this to me is a very meaningful journey. And as they say, happiness is only real when it's shared. So my happiness in sharing this with you is quite real. Thank you so much for being here. And well, see you next time.